Okay, here's the second question for Doppler effect. A truck is moving at 25 meters per second, emits a 400 Hz signal. Okay, the speed of sound in air is 343 meters per second. Calculate the wavelength between the source and a stationary observer if the truck is approaching the observer, moving away from the observer, and so on. Okay, let us identify what information given. Okay, this is the truck emit the sound. The truck emit the sound. So who's the source? Yeah, the truck is the source. The truck is the source. So the 400 Hertz should be the frequency of the source. Frequency of the source. Okay? Of source. And 25 meters per second means the source is moving. This is the speed of the source. The source is moving. The source is moving. Okay? And this is the speed of sound, V, just V. Now he find the wavelength. You want to find the wavelength, lambda, between the source and stationary observer. Observer is not moving. Okay? And the truck is approaching the observer. Okay. So truck approaching the observer A. Yeah, question A, truck is approaching the observer. That means the source is towards. Source is moving. You know, this is the source. This is the source moving towards the observer. Source towards the observer. So we can source towards the observer. So of course the wavelength is being compressed. Okay, we have the frequency of source 400, velocity of source is 25. So first find out the observed frequency by the observer. What do you think? What will be the frequency observed by the observer when the source moving towards the observer? Of course, you expected when source towards, you expect the frequency observed increase, isn't it? Increase. So here below we have Vs. The source is moving, so we have Vs. We don't have Vo. We don't have velocity observer because observer stationary. We have source velocity. So we need to put positive or negative in order to make the frequency increase. Yeah, we minus to make it smaller. Minus make it smaller, so frequency will increase. Yeah? Frequency observed. Okay, let's find out the new observed frequency, which is V is 343 over 343 minus 25. And then the emitted frequency, actual frequency is 400 Hertz. So the answer I get is 431.45 Hertz. Yeah, that is the new observed frequency. So now I want to find the wavelength. Now I want to find the wavelength. So the speed of sound is still the same, 343. But the observed frequency is 431.45. So what's the wavelength? What's the new wavelength? So I got 0.795 meter. 795 meter, which is also 79.5 centimeter. Yes. So this is the wavelength. This is the wavelength. Okay. Wavelength of the higher frequency, higher observed frequency. Now, which is being compressed. Yeah. When source moving towards, the frequency is being compressed. So I put this down. This lambda is 79.5 centimeter. Okay. Now, how about the second one? Now the truck, yeah, the source. Now the source is moving away from observer. Oh, now the source is moving away from observer. So we can expect when source moving away, source moving away, source away, source away. So we can expect the wavelength become longer. Wavelength become longer. It's like being expand, being pulled, being expand. When source moving away, we can when something away, observed frequency will drop. When away, so that means we need to make the below become higher. To make higher, here need put positive. We put positive, then below here become bigger. We add with something, of course, become bigger. So observed frequency become smaller. We have Vs below. Yeah. So let's continue. 343 over 343 plus 25. Okay, so the source frequency is 400. 400. So what's the answer? 372.826 hertz. That's the observed frequency. That's the observed frequency, lower than before. Yeah, because now frequency drop. Frequency drop. Now, let's find out the wavelength. Speed of sound is 343. And then the lower frequency now. So what is the wavelength? So the wavelength I get is 0.92 meter, which is also 92 cm. Oh, this time the wavelength become longer than before. Before is 79.5, now it's 92. Expected the wavelength become longer. You see that? You see that? You see when source moving towards, the wavelength is being compressed. The wavelength is being compressed. But when the source is moving away, the wavelength become expanded. Yeah, the wavelength become longer. Yeah, wavelength become shorter. This one wavelength become longer, expanded. So when the source is moving, you see both source moving towards, source moving away. As long as source is moving, the wavelength will change. Either become smaller wavelength or become a longer wavelength, a compressed wavelength or an expanded wavelength. When the source is moving. Now look at the last one. What will be the wavelength if the source now is stationary, but now is the observer moving at 25 meter per second towards the source? Okay, what will be the wavelength then if source is stationary? If the source is stationary, okay, now the source is stationary. If the source is stationary, then the wavelength is unchanged. Yeah, at the left hand side or right hand side, the wavelength is the same, unchanged. Although the observer is moving towards, yeah, although the observer now is moving towards, but it doesn't change the wavelength. The wavelength still the same. The wavelength, the wavelength of the wave, only depends on the source. If the source is not moving, stationary, then the wavelength is unchanged. So observer moving towards or moving away doesn't matter. Okay? So to find the last wavelength, which is unchanged, we just use back the source frequency. Just use back the source frequency. Okay, the velocity of sound is 343, speed of source, frequency of source is 400, and lambda, so my lambda now is 0.8575 meter, which is also 85.75 centimeter. Yes, so that's the, actually this is the original wavelength. Original wavelength 85 cm. When the source is stationary, the actual wavelength, this is actually the actual wavelength. We can say this is the actual original wavelength. Only after when the source is moving towards, then the wavelength become compressed, 79. Or when the source is moving away, the wavelength become expanded, 92 cm. If original is just 85.75 cm when the source is stationary. Okay, that's a wavelength when the source is stationary. Just use V equal to F lambda. No need to use any Doppler effect equation. Okay, so that's all for Doppler effect. Hope you like the video. See you again, yeah, in the next upcoming videos. Bye.